and I don't know what I did first time, but it was actually like really straightforward the second time, so not a problem. But so it's nice now. I have everything in the place that I prefer for it to be. And I've just been looking at this FIFO project, and
Yeah.
The good news is the FIFO project implements like 90% of what we need to use, and then basically we just have to put a couple more pieces in place and just link them together the right way, and that's essentially all that the project is asking us to do, as far as I understand.
Okay.
Yeah.
Yeah, and then I'll just ask him to look it over.
Yeah.
And if it doesn't have any errors, to just give me the grade.
Yeah, totally. So give me 1 second. I just wanted to grab those notes that I sent you. I didn't pull them from my Git repository. Yeah, that's fine. Okay. All right, yeah, and if you want to share your screen, we can just work on your computer. Okay. Oh my god. Well, I should have done that. Oh my goodness. All right. I need to clean this up, but I'll do that later. Okay, I can't look at them where I want to now. Fun. Okay. So sorry, give me 1 second. I'll do it the old-fashioned way. Sorry, I'm just trying to send myself that same document that I sent you so I can have it on another computer. But then I made the mistake of, so it's like on a GitHub repo that I have, and then I made the mistake of trying to pull the changes from that GitHub repo, and okay, I changed some things locally. All right, now there's like a bunch of conflicts, and I just don't want to deal with this right now. So
yeah,
it's always so complicated, God damn it, come on. All right. Okay, never mind. I know I have like 10 directories now. All right, whatever. Apparently I can't do anything I want, so that's fun. Okay. So I'm stuck on a tiny laptop with one screen. Cool. All right, either way, doesn't matter. Cool. So let's get oriented real quick, and then we'll start looking into some stuff.
Sure.
So, well, okay. I don't know. Maybe I should ask you where you want to start. I don't need to run the show.
I mean, I guess from the beginning, or what the assignment is asking. I don't know.
Yeah. Okay. So yeah, let's so you have that README document, right, that I sent you last time?
Yeah.
Okay.
Just 1 second.
Cool. great. Yeah, so basically, what we're going to do is take this existing FIFO model that they have, and then what we want to do is introduce this notion of users. And at first, we won't worry too much about any distinctions between these users. We'll just make two users that are exact replicas of one another. And we'll just do two at first because, why overly complicate things? And then the idea is like, all right, once we get it working with two, then we'll just introduce, some parameter to control how many there are. And, quite frankly, it doesn't matter how many you actually run the simulation for. It's like, all right, maybe we already did two, so now maybe we'll use three or something. But the
Yeah.
way that we'll write it will be generic, in the sense that we'll be able to just supply a parameter, in that like omnet pp.ini file, and then based on whatever number we give it in that file, that's how many users it will generate.
Okay.
Right. So we've actually seen some stuff like that before. And if you remember, it'll take a minute for me to point you to exactly the location, but it was somewhere in that last project that we were working on. They basically are able to write in the NED files. They're basically able to write for loops, and then you can essentially for I in whatever 0 to whatever that parameter is for the number of users that we set, do some stuff. So we can create gates and modules in the network just based on in a very generic way, which is super cool.
Yeah.
Okay. Okay, so either way, that's sort of the high level idea of how we're gonna do that stuff, and then they give us some different ideas on how to start making distinctions between the users once we actually have multiple users. Okay, fine. So that's just what that first part is about. The next part is, so basically the scheduler. I don't really know what they mean by the scheduler. Okay, it's just in the module as the same module as the queues. So in this FIFO model, we have this notion of a queue. So when we talk about FIFO, what does that mean to you?
First in, first out.
Yeah, exactly. I mean, it's that's essentially the interface for a queue, right? It's this is just some abstract description of the behavior, but this is what a queue should do for us. Cool. So I mean, it gives us some kind of notion of ordering, right, based on when messages are arriving. Cool.
Yeah.
So either way, our queues will be doing that, of course. And then essentially what we're saying is we're going to make it such that maybe actually a good idea would be to just go back into the omnet pp stuff and look at that FIFO project, and then in particular maybe check out that single queue.ned. You have it open in that right window. Yeah. Okay. So here's the diagram to think about. Essentially, I mean, the idea is we have some source that's just generating messages. I believe the source in this thing is essentially just the user, right? So here it's we have one user. This user generates messages, and we're calling that user source at the moment. Okay, fine. Those messages get thrown into some queue, which we call FIFO. And basically that FIFO thing has some sort of scheduling for how it's going to offload its messages. Okay,
Hmm.
fine. And then basically, all it does is as it's, processing messages or whatever you want to think about, it's just sending them to this sync thing. And we don't need to worry too much about sync. It's just some consumer of the messages.
Right.
Okay, cool. So that's sort of the idea that we'll keep in our minds. Um, but the difference with what we're doing now is we don't only have one source. In general, we can have n sources, and then at some point in time, we'll want to introduce priority levels to those. I think we introduce priority levels to the users, if I remember correctly. And then essentially we'll have different like queues associated with each priority level. So not only will we have many sources, we'll also have many FIFOs, right? And then, I think one sync, it doesn't really matter. Like we could just have, one big blob of a sync that consumes all the messages.
Hmm.
I'm not 100% sure about that part, but we'll figure that out as we go, basically. So okay, what questions do you have at this point, or do you have
No,
any questions?
I don't. I
Okay,
probably will in the coding, but not now.
okay. So that's the idea, at least. All right, so maybe can we go back to the that README? Okay. And so, all right, that's basically what we're talking about with this scheduler. And so they're saying that the scheduler is in the same um, module as the queues. So essentially, it sounds like we're going to actually implement this scheduler in that same OMAP module. Uh, which sort of makes sense. And I guess the way that I described it isn't like technically correct, because it's not like we'll have many of those FIFO blocks on our NED diagram. Basically, it will be one, but it'll be a little bit more complicated than the single queue FIFO that they're using in this sample, because we'll have, I think, what is it, like three, like a high, medium, and low priority queues. And then we'll have a scheduler that sits in front or behind, however you want to think about that, of the three queues that we have, and basically determines like, all right, if there are high priority messages, like those are the ones that get scheduled to go to the sync first. If there aren't any high priority messages, then medium priority messages are next, and if there are none of those, then low priority messages are next, basically.
Yeah.
Okay, cool. And then the sync, I don't think is like all that important, but basically the important bit of the sync is that we want to include these statistics. And so the nice thing about this FIFO example is that they do include statistics in it. So there's like, they've already kind of shown us how we'll do that. Okay. So I think that's a good starting point, is just to get ourselves set up to do all of that stuff.
Hmm.
Right. So maybe a good idea for today is we'll take this code. It might be a good idea to just like copy it into another directory, and then we can just start working directly with this code, but like in the ultimate directory that it will live in.
Where?
I mean, wherever you want, just like in the final directory that this project will actually live in. Like you probably don't want to be like directly modifying the sample files. You might want to put it in some other directory.
Here, I guess.
Oh, sure. I mean, like wherever you want. And just slightly tangential. I don't know if you're interested in Rust programming at all, but I decided that today I'm going to. So I'm like, like I know Rust fairly well, but I'm not like super comfortable with it. And there's a lot of really cool libraries that people use quite widely that I'm not familiar with.
Uh-huh.
But basically, I'm thinking I'm going to start like making some sort of content around Rust, and I think it'll basically just be me learning Rust, and I'll just I don't know, like post that for people to hopefully learn from. So if you're
Oh
interested in
wow.
learning Rust, I'm gonna start doing that and trying to hold myself accountable to like actually doing it every day. So um,
Yeah, definitely.
yeah, cool.
So
Um,
if you have that, if you make that, or the notes or lecture or whatever you decide to make, I would like a copy of
yeah,
it if you have, if
yeah,
when you
yeah, totally.
finish.
So I think what I'm gonna do is, and just to keep like the barrier to entry really, really low for myself, is I'm
Mm-hmm.
probably not gonna edit any of the videos or anything. I'm just gonna record myself with my screen and then just me learning. So like it's probably
Okay.
not gonna be terribly exciting most of the time, but I'm just gonna be like reading through documentation and then like coding some stuff and then reading through some more documentation and just like spouting off the random bullshit that I talk about as I think of things. And
Yeah.
yeah, I don't know. So that should be fun. And basically, I was inspired because I was given an assignment for a job interview, and it just totally kicked my ass. So now I'm like, wow,
Oh
I need to
wow.
learn about async programming and Rust. So that's going to be my focus.
Yeah, definitely. So
All right.
when you have
Um,
when you're finished or during your process. Yeah.
yeah. Yeah. Sweet. Okay. Cool. So you got. So this is like another directory now, right? All right. Perfect. So we'll just start modifying these
Yeah.
these files then directly.
So I can close people, right?
If it came from the FIFO directory, let's close it because we don't want to modify any of those like sample files. Uh, but if it's in your last CAD assignment directory, then let's modify that.
Yeah, the FIFA wasn't. And I don't think I need this.
Yeah, probably not.
This. I have no idea what this is.
This is so they did like a few. Yeah, and I didn't read through this part of their sample here, but yeah, it just looks like they stacked two FIFOs in sequence with one another, which I don't really understand why that's even interesting. It would be more interesting if they were in parallel with one another, and that's essentially what we're doing, you know. So like they did it like, oh, it goes into one queue, and then when it comes out of that one queue, it gets queued up in another queue, and then once it goes out of that one, then it's gone. It goes to the sink, which I don't see how that introduces anything more interesting to the simulation. But
Yeah.
what we're doing is definitely more interesting because now we like have all of these different queues that messages can go to respectively, and then a scheduling algorithm to like coordinate and orchestrate the um, flushing of those queues. I don't really know what to call it, but
Hmm. Okay, so give me just one quick second because I just realized
Mhm.
that I created it in the I named it incorrectly.
Oh yeah.
This is actually the file from the last lab
Oh
assignment, not
no.
the.
Okay.
Yeah. Close. There we go. Just gonna close all these out and just reopen them. Yeah. Okay. Empty project.
Nice. Oh yeah, sweet. Just to serve.
Cool. Now,
Oh, I see what I'm doing.
not this.
Okay. I think I see what I did wrong. Always something. All right, get serve. Let's get trigger. Do you use Git very much?
GitHub?
Yeah, but so GitHub is like just a website for displaying your Git repositories. So Git is the thing that I'm really talking about, but yes, GitHub as well.
Yes.
Yeah,
Not so
okay.
much, but yeah.
It's a real pain in the ass when you do it wrong sometimes. But
Yeah.
like feel myself getting much more proficient with it, and like I didn't even know that. Um, well, whatever. Like I said, I was trying to like sync my GitHub repository with my local one, and I made some mistake. But now I realize I can just abort from the thing that I was doing, which is really
Yeah.
nice.
It took me 4 years to figure out I can. You're not alone because it took me 4 years to realize that I can basically push and pull from Visual Studio
Oh yeah,
and
yeah. I
make
mean, that's
and
currently what I'm doing right now.
yeah. So sometimes this university is a pain
Hmm.
because they don't teach you the basic stuff. They just
Yeah,
go
you know
directly
what
in.
though? It's um, yeah. I mean, I have a lot to say about that, but definitely Git should be something that like every single class should be teaching you about and like reinforcing and constantly making you use. And like, that probably seems like a nightmare what I'm saying, but the thing about it is these tools and Git is one of them. Like they seem really opaque at first, but then once you work with it all the time, it's like, oh, this is actually very simple. And once you're comfortable with it, it's like you can just do things in 2 seconds that used to take you 5 hours because you just had to constantly read all the documentation. Um,
Yeah,
but yeah, I learned how to use Git through having a job in software development and then being like, oh shit, this is what you guys use. Okay, well now now I need to like learn this really quickly. So it was very frustrating and felt high stakes.
yeah,
But yeah, it's been about 4 years,
I
and
feel you.
now I feel like I finally understand Git a little bit better.
Mm.
Yeah. All right. Cool. So is the high level idea of what we're going for is is that clear? or what questions do you have about that?
It's pretty clear.
Okay.
I don't know if it'll be a difference in coding, but yeah, for right now
Yeah.
it's pretty clear.
Okay. This. Okay, sorry. One more time. I just want to have. Oh my God, you can't be serious. Okay, never mind. I don't want to figure that out right now. Um. Okay, cool. So, let's see. Let's check out. Oh wait. So, what files do we have in this project for maximum grade CAD directory? Because these look a lot
So,
like the. Oh, are these the ones that you sent me before?
yes, these are the ones that we
Okay.
got from the teacher, and I think are the
Yeah.
ones that we need to modify.
Cool. All right. So let's check these out then. So let's just open up at the very least, let's open up the NED files just so we can see uh, what the topology is looking like, and then we can go from there.
Mhm.
So let's maybe actually, yeah. So this one, let's keep it as this design thing, and let's try to get an idea of what's happening here. I think you should be able to. If you go back to that design tab, I think you should be able to stretch out that image a little bit to make it look better. Oh, you gotta be kidding me. Oh, one thing we can try is let's go into the source view, and oh, it doesn't have. Okay, I was wondering if it was gonna have. So sometimes when you go to that design view and you move things around, so actually let's go to the design view now, and let's just like adjust things graphically in there, and then we'll go back into the source and see how that changes the code. Yeah, so if you want to like stretch out that box a little bit bigger, and then yeah, and then just move some of those blobs in there around. Yeah, just separate them a little bit so we can tell what in the world is going on with all these arrows.
What?
God.
I don't want this. I want you.
Yeah, yeah. Let's get that guy down there. All right, that's looking complicated. Oh, it looks like so. Is it when you double click on it, it actually takes you
Yeah, it goes
into
to
that
the.
module? Okay. Yeah, and there may be a slightly nicer way to lay this out too, because it looks really complicated right now. But if you take that top one and like, I don't know, pull it down or inside or something, maybe it'll look just a little bit less complicated. All right, yeah, that's definitely looking complicated. So
I think
HPQ,
that's
I'm
a little bit.
assuming, is our high priority queue, and then we have our low priority queue and our medium priority queue, I assume, right? And
Hmm.
so, okay, and then we have this sources. Okay, so it looks like I don't know, and again, I don't know why they're calling it user in the project description, but then source in the
Yeah.
in this code. But either way, there's that's happening. Um, okay, fine, cool. So we got all of these queues. We have this scheduler that basically can send messages to any of the queues. Um, it's a little interesting to me right now that nobody sends messages to the scheduler. That seems weird. So the scheduler is only sending messages to the queues. Well, maybe that's not weird. So it looks like the users are going to directly, the sources are going to directly send their messages to whatever queue corresponds to their priority level, right? So if they're a low priority user, they'll send messages directly to the low priority queue. Medium and high are respectively the same thing.
Mm-hmm.
Okay. Then, well, we'll have to look at the code to verify this, but what it seems like we're saying is the only way that any of these queues are going to discharge any of their messages to the sync is when they get a message from the scheduler,
Mm-hmm.
right? So basically, that's how we're going to implement this behavior of, like I'll only send messages from the medium priority queue, if there aren't any in the high priority queue, that sort of stuff.
Yeah.
Okay. All right, cool. So it seems to me like we should probably look at this scheduler code and see what's going on there. And so typically the NED diagram is pretty helpful for looking at the network itself, but everything else it's not really all that helpful.
Mm-hmm.
Okay, cool. Oh, and this is the sort of thing that I was hoping to see. So this, like line 22, where it says, display, like at display, whatever. This
Mm-hmm.
is how they're making those images in the design view. So display like tells you about where these things are located. Yeah, so let's go in here. So now you see how it changed like the location. So apparently the way you say the location is P equals some like tuple.
Yeah.
Yeah. So okay, fine, whatever. So what I was talking about with those for loops in the NED file. So there's an example of that on like 57. Right. And so essentially what we're saying here is like, well, we have a bunch of sources. And we're treating sources as an array, right? So we can like access the index of this sources array. And so basically what we're doing is we're defining connections from each one of these sources with index I, where I goes from 0 to number of high priority users, -1, of course, always doing the usual goofiness since we start at the 0 index. But basically the idea is, so this source thing, whatever the source is, apparently it has some gate called TX packets. Right. Okay, fine. So if we want to see that, we could go to the source thing and see that there's a gate defined as TX packets, or at least there should be. And there is. Cool. So the thing to keep in mind here is this source is a single user. Right. So when we actually look at the network, it's an array of things of type source that we're using as like the quote unquote source.
Mm-hmm.
Okay.
Yeah.
Okay. Cool. Okay. Either way, so we got that. All right. So let's go back to our scheduler.
Yeah. Just 1 second.
Sure.
There we go.
That's right. And there's just about nothing defined here for us. So this is exactly what we need to be working on. Right. So this is so let's see. Well, okay. So all we should have in the NED file is just like what modules we have, what parameters we know about, and what gates we have. So what channels we're allowed to communicate on, especially. But all we're saying here is scheduler only has an output gate, right? Or many output gates. It has gate size many output gates, and gate size is something that we can probably define as a parameter, but it makes sense to just have it as 3 because essentially we're thinking there's one gate for each low, high, medium, high priority things. So 3 is like the right number, and I think that's why they set it as the default is 3. Okay, fine. So maybe it's not the NED file that's particularly interesting when it comes to the scheduler. It's probably going to be the interface in the implementation file. So let's check out scheduler.h and scheduler.cc.
Scheduler.cc.
All right, let's scroll down just a little bit here. Okay. And so just really briefly, the stuff at the top, I mean, okay, this is going to implement the interface in scheduler.h. That should be like totally expected. We do this define module thing, and that's to register the C++ module with ONET++, fine. And then we're like, the constructor for scheduler is just, well, we have some null pointer for this self-message field. Sure, whatever that is. Apparently there's a self-message field in scheduler. We could see that in scheduler.h if we wanted to. And then, all right, we have this, destructor. Doesn't really matter. It's basically the same thing every time. And then we have this initialize method, right? And so what we're saying is when we do a scheduler initialize, what's going to happen is we're going to grab this gate size parameter. So there should be in our onet pp.ini, there should be a gate size thing that we provide. Okay, and it's a parameter, which will also be reflected in the net file that we were just looking at. All right, fine. But then basically, we do this like self-message thing. So right now, that's all we do. And that's probably all we ever will do with initialize. But it's going to be handle message. That's going to be the interesting one. Because basically we need to figure out a way to have this scheduler know about the different priority queues that we have, because the scheduler is the one that's going to tell the queues to like offload some messages. And so for the scheduler to tell the right queue to offload messages, right, because we're worried about like low, medium, high priority stuff, for the scheduler to be able to tell the right queues to offload messages, I mean, we need to know what kind of messages or if those queues have any messages in them. So, okay. Well, either way, what this handle message method is doing at the moment is it's basically just saying, if it was that self message, cool, then we're going to do this stuff, otherwise nothing. And then basically, if it was that self message, so only the scheduler should be able to like communicate with itself, basically, is what that's enforcing. And so what we're going to do is now iterate over all of the users that we have. So this is like low, medium, and high priority users. And And what we're doing is just like making this command message and then sending that command message. So we need to see what send command tx scheduling comma I is all about. Right. So we've talked about that send function uh, in a slightly different context, I think, because basically, so the command is the message part. Well, that's maybe pretty obvious. The TX scheduling thing is the gate, or yes, the link or the gate that we're going to use in the scheduler, right? So TX scheduling is that thing that corresponds to scheduler. In the scheduler.net file, we have that output gate called TX scheduling.
Mm-hmm.
Okay. Um, and so, how many of those TX scheduling? Uh, so, TX scheduling was like many gates, and how many of them do we have, and why?
How many do we
And
have of
you,
what? Because you cut it out for a few seconds.
yeah, the TX scheduling gate in the scheduler. Yeah, how
Mm-hmm.
many? How many? Uh, so that's like we're calling it by one name, but really it's like an array of gates. So how many elements are in that array is the question, and then why?
Uh, I don't know.
Well, so if you're not sure, we can go back to the scheduler.net file,
So
and then
three.
basically, yeah, it says three, right? Okay, now
Okay.
so
Yeah.
there should be three. I agree, and so then essentially what that last parameter in send is doing is it's like that's the index that for that gate size thing, right? So like TX scheduling is like an array, and what we're doing is we're saying, index 0 will correspond to something. We'll make a decision whether that's, low, medium, or high. But basically, the 0 index will correspond to one, either high or low, probably. It'd be real weird if you did like medium, high, low, or something. That just seems strange. So, like, in my mind, it makes the most sense to do low, medium, high, or high, medium, low. Um, but either way, it might be a good idea to write a note here, like under that output gate, and just say, okay, let's make a decision right now. We're either going to do low is the 0 index, medium is the 1 index, and high is the 2 index, which that sort of makes the most sense, in my mind at least.
Neither. I don't know what's going on with the audio. Hopefully, it wasn't.
Oh, here, let me switch headphones. All right. Can you hear me okay now?
Yeah. No. Yeah.
Okay. All right. Perfect. Yeah, I don't know. Those headphones a little finicky sometimes. Okay. So yeah, basically, we're just going to make a decision on which index of the TX scheduling gate corresponds to which queue, right? So basically, we have those three queues. Um, here's my suggestion. My suggestion is the index 0 TX scheduling thing should correspond to the low priority queue. Index 1 should correspond to medium priority. Index 2 should correspond to the high priority one. Yeah, but we need to start at index 0, right? So we'll do index 0 for low priority,
Oh,
and then
okay. Yeah, yeah.
1 for medium, 2 for high.
Oh,
Okay, cool. Yeah, perfect. Okay, so that's what we want, right? And so we always need to be careful, especially when we're taking code that somebody has given to us. We always need to be
hmm.
very careful with drawing a distinction between what we want and what the code is actually doing at the moment. Uh, because if we go back now, we'll see it's very much not doing what we just said. So this is what we want. 0 is low, 1 is medium, 2 is high. So only 0, 1, and 2. Those are the only indices we should ever touch. Fine. Now let's go back to the scheduler.cc and see that it does not do this. So first things first, look at the for loop. How many users do we have? Well, oh, interesting. Okay, so they're saying, oh gosh, why are we using different names for the same thing? So, okay, can we need to change that name, number users, because this is like not even true. It's not the number of users. This is, I mean, if you want to call it something other than gate size, we should probably call it number of priorities or something like that, because there's in general n users, right? But they fall into 3 groups. So number of groups is maybe a better way to say it. Uh, it's a little confusing, and we should make our terminology as consistent as possible.
But it
Because
should correspond to this, right?
yeah, so it should be equal to gate size, and gate size is 3, right? Because we set the default as 3, and that's what
So I
gate
can just
size
say gate
is.
size.
Yeah, and then the only thing is we'll have to change the scheduler.h as well, because now it won't implement what we said. Yeah, and
Yeah,
I
I
don't I
just
don't know if there's any. Oh, no, yeah, we just had a capital thing there, so it should be fine. Okay, so let's open up scheduler.h as well, and let's
or
make
should
that
I
same change.
or should I say like this?
You can write it however you want, I think. Some languages care if the
Yeah,
fields are lowercase or capitalized. It seems like C++ doesn't care.
I think my teacher cares.
Okay. All right. So let's go to
Yes,
scheduler.h
sir.
and let's make that change before we forget about it. Yeah. So here, yep. Let's change that field. Yep. Yep, perfect. Okay, great.
I'm
So
gonna write a
now,
comment.
yeah, absolutely. Yeah, and in fact, it's probably better to write more comments than not enough. You can always delete them. You can't always, get access to exactly your state of mind when you are writing the code, though, in the future, unless you write comments. Yeah. Okay. Cool. All right. So now that we change, yeah, I mean, and you can even close scheduler.h because, well, let's look at it real quick before we close it. I don't think we'll need to make any more changes here because it doesn't really say very much. All scheduler.h says is we got a constructor, we got a destructor, we have this self message field, we have this gate size field, which we just called it that, right? Yeah, this one's the destructor. And then, so it just defines these 2 fields, and they're private, and okay, it doesn't really matter that much. And then we have these two methods, right? The initialize method,
Yeah.
which is already set up for us. We don't need to modify initialize at all. We're just modifying this handle message method.
Right.
Okay, and that's literally all that's here. This is an interface file. You don't put logic here. You just put like constraints, basically. Okay, cool. So we
Okay.
could just close this out. So it's like, don't even ever need to worry about this again for now. All right, great. So now what we're saying is when we initialize, we set our gate size parameter, fine. We set that self message thing and we schedule a self message. Cool. Okay. Now in the handle message, what we're doing is we're going to iterate over all of those indices for the TX scheduling gate. So we do 0, 1, and 2, of course. Wait, 0. Why would it be strictly less than gate size? Oh, gate size is 3. Okay, I'm an idiot. Yes, that's right. Perfect. So all we're doing is we're making this command message, and I think we get to choose like what that is, and whatever they're just calling it command. Fine. But then we do this send thing, right? And so essentially what we're saying is we're going to send this command message that we just defined on line 46 to whoever is connected to the ith index of this TX scheduling gate, right? TX scheduling is an output gate, so we can send messages out on TX scheduling, of I. Okay. So what questions do you have about this, or is that clear?
Pretty clear.
Okay, cool. And then so that's all we do in the for loop. And then after the for loop, we just say, okay, we're going to schedule another self message to then basically go loop through and send those command messages out. But we're going to have a little delay there. And the delay we call scheduling period, and apparently it's a parameter to the model.
What is the self message?
So self message is the thing that scheduler sends to itself to then basically start scheduling message. So it's a little bit funny, right? Because the only way that these OMNet PP modules do anything is when they read messages, right? So in order for the scheduler to be able to tell itself to do more work, it has to send itself a message, right? And so basically, when we construct the the scheduler thing, and then we do the initialize method, all initialize does is it sends itself a message. But now it has a message. And so then handle message is what it uses to actually process the message that it has. Okay. But what we're saying is in handle message, so we consume this self message, we send some messages out on this TX scheduling, like the different components of TX scheduling. And then we send ourselves another message so that we can basically just keep looping through this behavior of like sending these command messages out on these 3 channels. And then we send ourselves a message so that we can, make 3 more messages, 1 for each channel. But we put a little bit of a delay in between each iteration of this, and that's what this scheduling period thing is about.
Okay.
All right. But notice right now, all we're doing is the scheduler, every single time it loops through that, it's just sending command message to each of those queues. Right. To all of them. Okay. So we'll keep that in mind. All right. Cool. Maybe it's a good time to check out myq.net. And the design tells us nothing basically. But okay, so here we have. All right, it has three gates apparently, two inputs and one output. Um, all right, fine. Um, what I can tell you is more than likely this RX scheduling gate is going to be the one that is receiving messages from the scheduler. Right. I don't really know what the RX packets thing is yet, but we'll figure that out. And then the TX packets output gate, that's going to be how it offloads messages to the sync, right? So this is basically like how we'll take messages out of this queue represented by this MyQ thing. Yeah. Yeah. Okay. And I'm not really sure what this RX packets thing does yet. So I mean, either I guess you could say not sure what this does, like look into it or whatever. Usually I leave a to do comment to myself if I don't know what something is. Yep. Cool. All right. Sweet. So this is only the NED file for this thing, so it's not like super interesting. Yeah, and I'm not 100% sure what the number of inputs thing is yet either. But let's look at myq.cc to see the actual implementation. Okay. So it looks like.
Close some of these out.
Mhm. Yeah, some of the NED files aren't terribly useful, but I think the scheduler one is probably the network one is as well. MyQ is not terribly helpful. Oh, and I'll have to get going here in like 2 minutes, but
Okay.
so let's check out MyQ. So again, we do the define module thing to register it with .NET fine. We do this initialize thing, which does this set name thing, which is not super important for us right now. But the handle message method is important. And so basically what it's saying is if we have a message and it arrived on this channel RX packets, right? We were talking about saying we weren't really sure what that was. Apparently somebody is sending us messages on RX packets. And what we're going to do when we get a message on this RX packets channel is we're going to put it into our queue. Right. So we have some queue data structure that we're using here. And so all we're doing when we get a message from RX packets is we throw we throw that message into the queue, right? Okay, fine. And then it's saying otherwise, if it's not coming in on RX packets, well, then really, I mean, the only other option is that it's coming in on RX scheduling, right? And so if you remember, RX scheduling is the channel that we're getting messages from the scheduler on. And so what we're going to do is, they have some comments here, but we're just going to look at the code for right this second. And what we're going to do is, delete that message. Fine. So deleting that message means we don't want to send the scheduler message along to the sync. It's only the stuff on RX packets that will ultimately get sent to the sync, if that makes sense. So that's
Yeah,
why
it
we
does.
want. So that's why we want to delete on line 34 the scheduler message. Okay, and then basically it's just saying, well, we're gonna empty the queue after we delete that message, right? So they're doing it with a while loop. They're just saying, well, it's not empty. We're basically gonna pop it off of the queue and put it onto TX packets. So what I can tell you is more than likely TX packets. Well, we already know that it's an output channel for MyQ. But what is more than likely the case is that TX packets will be hooked up to an input channel in the sink.
Yeah.
Okay.
Okay.
So yeah, basically what we're saying is if we get some message on RX packets, we throw it into our queue. If we get some message from the scheduler, then we basically like flush the queue and put all of those messages one by one. We send them on TX packets.
Yeah.
Okay. All right. And I got to get going, but what questions do you have at this point?
When is your next? Would you have early availability?
um, yeah. So, I mean, so let's see. I have availability around this same time on Monday, on Tuesday.
Let me just check something real quick.
Yeah, sure.
Monday, Tuesday.
Yeah, either
Let's
or
do.
both.
Oh, uh, let's do Tuesday.
Tuesday. Okay,
Yeah,
let me see. So
I'll let you know if
Tuesday.
something
Yeah.
happens.
Okay. Tuesday, 9 a.m. your time.
Yes.
Perfect. Okay, that sounds great.
Awesome. Thank you
All
so
right.
much.
Yeah, you're very welcome. And we'll just
How'd it go?
pick up basically right from this network diagram and just go from there.
Okay. Awesome.
Okay, awesome. All right,
Thank you.
I'll see you on Tuesday. Yep.
Have a good one.
Take
Bye.
care. Yeah. Bye bye.